We know, oh, sorry, yeah, animation thing, yeah. So let me see why. Why I missed some animation in this one. All right, also other questions, yeah. Others should be fine. All right. Others should be fine, all right. So share again. All right, okay. Yeah, the first question, number 13. Retrieve the names of all employees who have supervisors. Yeah. You can have different ways. Yeah. So when I do the grading, I just use the logic. Okay. So if your answer makes sense, you know, follows the natural logic, and yeah, because in order to save time, I do not do the testing, right? Yeah, I do not do the testing. All right. Yeah. So here, the answer, one of the answers, we can do this way. We join two tables. We set condition. Yeah. Yeah. Right. Yeah, because we want to see the supervisor's SS underscore SSN is a valid SSN, not a null value, because this selection condition won't select the null value. Okay, yeah. So this is one way, but you can use another way. We check the null value, not null, right? Yeah. In that case, you don't need to join two tables. Here we join two tables. So many students, I believe many of you use that not null way. Supervisor underscore. Yeah, yeah, not no. Yeah, because is null, right? Yeah, we have is null operator, but not, right? Okay. Yeah. All right. Or, yeah, because is null and not. All right. Yeah. So, yeah. I mean, consider that way. Yeah. You know, just, you know, check this not null value. Okay. Yeah. Find a way to check this null value. Okay. Yeah. All right. Number 14, list the first name, last name of those whose first name have no more than 5 characters. Yeah. All right. So one way if you use the length function, the length of the first name less than or equal to 5 and greater or equal to 1. That's one way. Okay. But you can also use regular expression. This one is regular expression. Yeah. You start your string with any character and you repeat this many times between 1 and 5, 1 comma 5. Yep, so that's another way you can do it. Okay, yeah. Yeah. All right. Next question. List the project names and the names of those employees who work on project exact 40 hours per week. In that works underscore on table, we have this information. Okay, who works on the project exact, yeah. You need to get the total number of hours for each employee. Yeah. All right, yeah. So here you join 3 tables: employee, project, works underscore on. Yeah. Then after that, yeah, exact 40 hours per week. Right. Yeah, because that number is based on each week. Okay. Yeah. Project number. Yeah. Just a minute. Yeah. So project who works on the project. Oh yeah, the project. Yeah, just one project. Yeah. Here. Yeah. 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 Here. Because the meaning here on that one project, 40 hours per week. Yeah. It's not total. Yeah. Because we know one employee can work on several projects, right? Yeah. It's possible one employee can work on several projects each week. Here, counting based on each week, number of hours each week. Here, how about if I ask you total number of hours in each week? Yeah. So let's assume the total number of hours you add from that table, works underscore on table. That's for 1 week. Yeah. So you just apply sum function, right? For each employee. You apply the sum function right? Yeah. Group by, yeah, because you expect to have a group. You define subgroups. Each employee, it's ESSM, you use that number to define a subgroup. Then you can call that sum function in that subgroup, on that subgroup. So you have a total number. Okay, yeah. So if I modify this question to all the projects with total hours each week, 40 hours, total 40 hours, then you can change in that way. Okay, yeah. Modify slightly on this statement. Yeah. All right. Still, when you do the table join like this one, but you need to define group by, right? Yeah. All right. So the select condition, so yeah. because this one you can apply sum on that, but you have group by. Okay, yeah. Define subgroups. All right, yeah. All right, yeah. Next question. List the first name, last name of those employees whose addresses contain no digit other than the street numbers. Street numbers, you can use digits, but after that, after the street number, that part, the remaining, the address remaining, you cannot have any digit, this condition. All right. Yeah. So one way you can do regular expression first, this is the street number part. Street number part. All right. Yeah. You start the address string, start this notation, yeah, with one digit repeated one or more time, that plus sign, one or more time. After that, the space character, this is space character. Then you complete the digit, the street number part. After that, because you cannot have any digit character after that. So here, not, right? Yeah. Not exclude, yeah. That inside that bracket, excluding the digit, not digit, okay? Not digit. That one character repeated 0 or more time, that star 0 or more until you reach the end of the string, that dollar sign, end of the string. Yeah. If you do not have the dollar sign, then because after that star, you can have a digit after that, right? Because after that star repeated, the remaining characters doesn't matter. Anything is okay, right? Yeah. After that star, non-digit character repeated certain number of times, anything is fine if you miss that dollar sign. But if you put this dollar sign, you cannot hit any digit until you reach the end. Even you reach the end, there is no digit after you pass the street number. Yeah. Think about that. All right, yeah. Okay, so that's the regular expression way. Yeah. All right. Number 17, list the first name, the last name of those employees whose addresses contain $1 sign and one dot. Yeah. So here, $1 sign, one dot, not exact $1 sign, not exact one dot, okay? Just contain at least $1 sign and at least one dot. Yeah. So you separate two parts. The first part, just $1 sign. Yeah, you check. The regular expression contains that $1 sign. All right. Then, and yeah, because another one, right? Another regular expression, only it contains at least one dot. Yeah. So two parts you put together. Yeah. So here, the first part, because dollar sign is a special notation, you need to use double backslash. Okay. Nothing more, because this way, your string only needs to contain at least $1 sign. Okay. Before that dollar sign, anything is okay. And after that dollar sign, anything is Fine. Yeah. So, and another regular expression, double slash, that dot, double slash, only one, at least one. Yeah. Okay. Not exact. If exact, then much more complicated, right? If you need to represent exact, then you need to do more. Yeah. Yeah. All right. Next one. List the first name, the last name of those whose addresses contain exactly one dot. Yeah, this time exact. First, at least one, the first part. Second, you need to represent. You cannot find two dots in the address string, the whole string. You cannot find two dots. Okay, yeah. These two dots not necessary back to back. The two dots anywhere in the string. All right, yeah. Yeah. So also two regular expressions. The first one, at least one dot. Second one, not. Yeah. Second one, you need to use the not that regular expression. Then you write two dot pattern. The pattern representing two dots in a string. All right, this logic. Look at the first part, easy. Yeah, we did in the previous question. But second one, not. Okay, how to represent two possible separate dots. Two possible separate dots. Okay, yeah. The first dot. This is the first dot. Double slash dot. The first dot. After that, that dot represent any character, right? Yeah. Any character. Repeated 0 or more time, that's star. Any character after the first dot, repeated 0 or more time, then another dot. Okay, yep. So this expression, at least two dots anywhere in the string. Okay, yeah. So that's the exact one dot. So you can see much more complicated than that, at least one dot. You need to, so, yeah. You may use different ways, yeah, but I need to check your logic. Okay, yeah, basically I check definitely the syntax. I also need to make sure your syntax is all right. Okay, reasonable, all right, yeah. But based on the, you know, the pattern, expressions, and the logic. Yeah. All right. Next question. List the first name and last name of those employees. The supervisors are department managers. Yeah, the first thing, yeah. Many students, also based on my previous few semesters, some of the students, they confused with the two concepts, supervisor concept and department manager concept. These two are two different concepts. Supervisors and department managers, different groups of people in a company. Okay, yeah. And in our company table, they have different representations. Supervisor, you use employees, super underscore SSN, and the manager uses department table, MG, manager, MGR underscore SSN. Yeah, different ways, separate. Yeah. That's the first thing, yeah, because many students ask me, ask me if these two are the same concept, different. Okay, different. All right, so then here, yeah, here I'll give you two solutions. The first one, first, we need to find supervisors, SSN. After we get that, we want that number, SSN number, we use in operator, because we can get the list of all managers SSN from department table, right? Yeah. We can use one inner query to get the whole list of managers SSN. Then when we have a supervisor, we just check if that supervisor's SSN is in that list. This is one way for the representation. Yeah. But you can also use our regular, usual table join, yeah, because after you get super underscore SN, can you compare it with managers SSN? Yeah, you can also do that here. So we join three tables, 2 copies from employee table and department table, but this time yeah, super SSN. Okay, yeah, right. Yeah. But I think you may simplify, yeah. Although here, this statement is based on the straightforward logic. The question, can you simplify it, right? Yeah. Why you need 2 copies, right? Why you need 2 copies? Oh, yeah, that makes sense. Yeah, the reason you need 2 copies, yeah, because the employee, yeah, you need to get employee's name and first name, last name. Not supervisor's first name, last name. Employee's first name, last name, right? Yeah. But how about this? Yeah, although employees, but it doesn't matter. How about this? Yeah. Okay, so here, let me just simplify it. Yeah. We do not need a second copy of employees. Okay, we just take the first copy. Yeah. And this join condition basically give us the employee is not null, right? Yeah, but this select condition already contains that information, because if it's null, we cannot select it when we compare with the manager's SSN. So we can skip this part. We don't need this part, okay? Yeah, so we just compare super, yeah, but not a E. Yeah. We don't have S copy, right? E dot SSN. Okay. Yeah. Employee. This current employee's super underscore SSN is a manager. Okay. Is a manager. Yeah. Okay. Yeah, oh, yeah, this should be our old way. That also should be E, right? Not S. Yeah, because S, that's a supervisor's copy, right? Yeah, so it should be E. We know this employee's supervisor. Oh, okay. Yeah, all right. Sorry. The supervisor's supervisor. Oh, yeah, we need, sorry, we need that S copy. Yeah, sorry. Yeah, because I missed that part. I missed that part. Yeah. If I say whose supervisor is a manager, then we don't need a supervisor's copy. But here our condition is supervisor's supervisor. Yes. So we need a supervisor's copy. Yeah. If I just say this employee supervisor is a manager, then we don't need that supervisor's copy. Yeah. All right. Yeah. Here. Yeah. When we read the question, yeah, so we need to pay attention to the little detail part. Yeah. All right. Yeah. Next one. List those departments whose managers are older than 50 years old. Yeah. Because we have that information, the manager's birthday. So we use the employee's birthday, not manager. Yeah. So first we get that manager from, employee table, because we need this B day information. Then check older than 50 years old. Yeah. Okay. Yeah. All right. Then list the last name, first name, and the year born for the employee who was born the earliest in the company. Yeah, we have many different ways. Here, I give you 3 possible solutions. The first one, we use order by. Yeah, so the earliest, we order by that B day ascending order. Yeah, the smallest corresponds to the youngest, not youngest, earliest. Limit by 1, the first one. Yeah. Yeah, so that is 1. Yeah. Another one, we find the employee then in this inner query, we find the minimum of the B date. Yeah. Because the second one, in the second one, if we have more than 1, yeah, because the first one will only find 1 of such employees. If we have more than 1, you only find 1. But the second one, B date in that select minimum, that number in, yeah, you may find more than 1, right? Yeah. Yeah. Anyone in this group, earliest, if several employees, they were born same day and all the earliest in the company, so you can find multiple employees. So that's the difference. Okay. Yeah. And in this one, a simple way, yeah, year function, yeah, because here the year born, right? You only look at the year part. The year of that minimum of the birthday. So you apply that minimum aggregate function, you select the minimum value first. Okay? Then you take the year part of that minimum birthday. Yeah. Yeah. So this is a simple way. It's legal. Yeah. This way also legal. Yeah. Okay. Yeah. All right. Yeah. So many different ways. Then the last question. List the first name, the last name of each employee who has more than 2 dependents. Yeah. So we do not check spouse or children, total more than 2 dependents, and who is making 50,000, more than 50,000. Yeah. 2 conditions. 1, the salary condition. All right, yeah, from employee table. But second, the inner query. Inner query, the count function on dependent greater than 2. Here you can see the questions in this part are relatively easy, yeah. Not too complicated, yeah. All right, yeah, but just practice, you know, so you need to get some experience, all right, yeah. So here, we'll practice, yeah, a little bit. All right, so we complete the query part of homework assignment number 2. Yeah. Now, let me stop for some time and see if you have midterm questions. Yeah, give you a chance to ask midterm questions. Yeah. All right. Yeah. Any questions? I can jump to the, you know, the midterm test paper. Yeah, this is the midterm, our midterm test questions. Can anyone give me if you need me explain, okay? Yeah, if you feel nothing to explain, then it's okay. Yeah, I can go to the concept questions of homework assignment. Do you need me explain this question number 15? It looks a little complicated, yeah, but actually, you know, yeah. Yeah, let me explain a little bit. Yeah, 15, yeah. Yeah, 13 also? 17. Oh, okay, all right, yeah. Number 15 first, yeah. Yeah, but here, 2 concepts here. Yeah. Try to separate these 2 concepts, so do not confuse. One is union compatible, another is cross product. Cross product, okay? Yeah. So A and B union compatible. So you understand the meaning, right? So here I do not repeat the definition. So you know, you can apply the union operation on these 2 tables. Yeah. And C and D also union compatible. All right, yeah. But now we do cross product, A and C cross product. And then B and D cross product. A and C cross product. We know any 2 tables we can apply cross product. Okay, so we do not need to check any condition. It's legal. Similarly, for B and D, it's also legal. But the good thing is A cross C and B cross D, they are also union compatible. Yeah, because A union compatible with B, C union compatible with D, after you do cross product, then those 2 new tables also union compatible. So you can apply set operations. Here we apply union OR operations. Now we want to count the total number of rows in that union OR operation. First, you need to know for each table, A cross C, how many rows in A cross C. Yeah. You also need to know how many rows in B cross D. Then union OR, remember we have one example. We in our last review class, we have one example, the total number of rows when we apply that union OR operation on 2 tables. Right? Yeah. Yeah. So then you can find one expression at the bottom option. Yeah. Yeah. So based on that understanding, yeah. Otherwise, so many options, you may get confused. So which one? Yeah. So based on the structure, yeah. So you can figure out, yeah, 2 parts, cross product. How do you count the number of rows in cross product? And how do you count the number of rows in union OR operation? right? Yeah. So that's the number 15. Number 17, yeah, let me help you understand the meaning of number 17. List the first name and last name of all the managers in the company whose departments have the maximum number of employees among all the departments. Now, all right. You have different ways, right? Yeah. So here you can go back to our, homework. Number 2, max, that the birthday, right? The minimum, the year, earliest, yeah, similar to that. Yeah. But here it's slightly different. Maximum number of employees. You need to count the number of employees, right? Yeah. You need to first, for each department, you need, so here you may need to do in 2 steps. Yeah. 1 step, you count the number of employees in each department. Yeah. Group by department, right? Yeah. Group by department. All right. Yeah. So each department, you have a counting number. Yeah. So that's 1 table, right? Yeah. So then 1 table, the maximum number. Yeah. So you need to find that department number with the maximum, that the number equals the maximum. Okay. Yeah. Yeah. So yeah, here, right. Here you need to, so yeah, here you need to organize your information. Organize your information in a relatively simple way. I hope you do not make it too complicated. Okay. Yeah. All right. Yeah. Okay. Yeah. One way you can solve this problem, step by step. First, how about we do this? We list the department numbers and count the number of employees in this department. Can we do that? We list the department number and count the number of employees in this. We only need to use employee table, right? Think about it. In the employee table, we have the department number information. And we can count based on the department group by department number. We can get that information. All right. So that's one table, temporary table, right? Yeah. 1 table. That's 1 table. You can use the alias represent that table, right? Yeah. So you can assume you have that table available. So you can use the alias represent that table. Yeah. After that, you can get the maximum number, right? Maximum number and its corresponding department. Yeah. Or, yeah, because the next round, you need to find the manager information for that department. Manager information for that department. First name, last name of the manager. And that manager, you have the department number, and that counting number is the maximum. Yeah, that condition you need to represent. Can you use the in operator to do that, right? Yeah. Can you find the maximum net counting number? Yeah. Here, let me bring back a similar question in our homework assignment. Okay. Yeah. So let me jump to a similar question. We can use that. Okay. Yeah. Let me use a similar question. Yeah. Yeah. This one. Okay. Yeah. This one. All right. Look at this question. Look at this question. Look at the second solution, this solution, all right? This solution, all right. Think about this table. Can you use the inner query to find the maximum number of employees in a department? Yeah. And then can you get for a department manager that count the number of employees in this list, this table, right? That's one way. That's one way. But this way, pretty complicated. This way, pretty complicated. Yeah. Because you need to, first, you need to get that table number and the number of employees in that table. A temporary table with alias for that table. You have that. Okay. Then you need to use that table. Yeah. Yeah. That table. Let me see. Yeah, because that table in that way. Yeah, so here, yeah. So this one a little challenging, Yeah. This table you can join, right? Yeah, think about you can join. Use another table join with this one. Yeah. Use our usual way to join different tables. This one, because you have alias, so you can use its alias to join with other tables. Okay. Yeah. So then you write your query, treat this table as a regular table. Although in our company database, we don't have this table, but you can generate this table and use an alias refer to this table. Okay. Yeah. Yeah. All right. Yeah. So yeah, try your best. Yeah, try your best. Yeah. It's a little challenging. Try your best. Okay. Yeah. All right. So let's look at other questions. Other questions. All right. Yeah. Probably that one is relatively challenging. Yeah. Oh, question number 9. Yeah, I don't know. So if, because I remember in the class, I mentioned this a little bit. Yeah, but here I like to recall a little bit. Yeah. Because some of you may forget. Some of you may forget the details. Yeah. All right, so here, which of the following numbers cannot be represented precisely in binary format? We know when we represent a number in a computer, we need to use the binary format. But when you represent it, some of the numbers you cannot represent precisely. You have to truncate some digits. Yeah. Here, some of the numbers we can represent precisely, but some of the numbers we cannot. But here you need to use the binary system, not decimal system. For the decimal systems, all these numbers, we do not need to do truncations, right? Yeah, that's the decimal system. No truncation needed. But think about if you represent it in the binary format, then you may need to do truncation. Yeah. So here, why? Let me explain that. Yeah. Because the binary representation here, that means 0. You can only use bit 1 or 0, right? Yeah, the binary system 1, 0. You can only use 1 or 0. Think about that. Okay, that's the binary system. Think about this one in this position corresponds to 1/2, right? Yeah, 1/2. Okay, yeah, or 2 to the -1, that power, all right? This corresponds to 2 to the -3rd power, right? This one corresponds to -4th power, and so on, right? So you can see here it's a summation of 2 to the -j power, okay? Yeah, let's say, yeah. Actually, those numbers that can be represented precisely has this format. How about that? Bj equals 1 or 0, 1 or 0 times 2 to the -j, that representation. You need to think about this representation. If you use finite number of bits, to represent precisely some floating point numbers, which one you cannot represent precisely? That's the question, okay? Yeah. In these 4 options, which one, if you use the format like this, which one you cannot represent precisely? That's the meaning. Okay, yeah, yeah. If you use this understanding, then you can answer this question easily. Yeah, because the format is like this. Do not use our decimal representation. Okay, yeah. All right. Yeah, so that is this question, number 9. All right. For other questions, I think quite normal, right? Yeah. So we practiced many times before. Yeah. Quite normal. Yeah. Yeah. This number 11. When we learn the foreign key, yeah, we talk about that. Okay, yeah. So referencing table, reference the table, and that rule, you know, the foreign key constraint, the rule for foreign key constraint, yeah. So this one should be fine, yeah. All right, yeah. This number 12, we did similar questions in our homework assignment. Yeah. And the order is important. So when you do the counting, do not use that combinatorial numbers because you do not consider the order information. Yeah. You need to use that product rule. Yeah. All right. Yeah. And then number 13, we did a few examples. Yeah. And remove the duplicate copies. Remember that? Yeah, duplicate copies. Yeah. All right. Number 14, we did a similar example. Partition, the definition, 3 conditions, right? Yeah. Go back to our review, last review session. We did a similar question. Yeah. We just use that example. Yeah. All right. Yeah, I think, yeah. That's the midterm. Yeah. So if you just study our old questions, you should be fine for these midterm questions. Okay. Yeah. Yeah. All right. So any other questions? All right.